Okay, I have started the meeting now. It is 2:58 p.m. Waiting for 2 minutes.
Preferably, I think we can start with the RAG uh,
Yeah.
basics, right? If you have gone through the RAG, let me know anything specific. Otherwise, we can generally start speaking. Even I need to brush it up a lot. I was planning to brush up specifically three areas in AI from my MTech. One is ML, machine learning.
Mm-hmm.
One more is DNN, neural networks, and one more is NLP. Okay, I feel that these are the like core areas in uh, this one AI, because it will give you the core understanding of AI, right?
Hmm.
But whatever now going on in the industry is mostly over NLP, which is conversational AI.
Hmm.
Okay. So,
Hmm.
like you say, agents, even the RAG, all these things, right, are
Hmm.
more onto the conversational AI side.
Hmm.
Okay, but then, yeah, I'll ask one question. So, anything on the RAG, did you guys get a chance to check that video or any other things?
Yeah, I
Okay.
got. I
Yes,
just before the meeting, I checked the video. Okay,
Okay.
Arun, you were saying.
yes, Pawan. I had gone through the plan because we discussed last week. So I had
Okay.
gone through that. So on one more thing, Pawan. I think we have. LangChain and all. What
Uh,
we should focus on. In the case of LangChain or to understand the code. Like,
bit voice is bit shaky, okay. But you are asking about
uh,
LangChain in LangChain library, what to focus on?
what to learn. What to focus on. LangChain. 1 minute.
I think I didn't get the question fully. Vinal, did you get it?
And a lot of noise in the
Uh,
background for me. Yeah.
Okay, but LangChain is a library. I think there are a lot of related libraries, LangGraph,
so what we should
Lang.
focus on in this case?
Okay, honestly, I haven't used LangChain much. Probably for some small projects, I have used LangChain. Um, I I don't know if you really need to focus on LangChain. I think preferably you would focus on the fundamentals or understanding of, say, agents or how you build the multi-agentic, all those things. Maybe design patterns on agents, all these things. Um, LangChain, maybe a next level, I would say, after I have understood all the things. And I have not. Use the LangChain, because even if you are going to use the LangChain, right, I don't think so. We will get into the code level nowadays, right? So yeah, maybe one thing is that where you will use LangChain, where you will use LangGraph, or one more thing is there, I guess, LangFlow, these libraries. Um, Maybe if you have used LangChain and you can say that, okay, I have used LangChain in the interview, right? That will add a value. I agree to that. Okay. But I have not used LangChain. I have done the agents, but not specifically used LangChain.
Okay.
Yeah.
I have 2 cents to add in this. I was exploring LangChain and LangGraph, and I got to know from a few videos from the industry experts that LangChain has taken a back seat, and LangGraph is being used now. And this whole thing is part of one big ecosystem, Arun. LangChain is the company and the framework as well, and LangGraph is also the new framework, which is a graph-based framework, as the name suggests. right?
Right.
And there you can actually, what you said, you can actually decide the flow of execution amongst agents. You can define your agents, you can decide how the control will flow through the agents. So I mean, if you have to focus on any framework, there are many, okay? There are many frameworks to create agents. I mean, LangChain and LangGraph are one of them. Like you have the OpenAI, the best one is the OpenAI Agents SDK, okay, which I know of, which can give you full control over what you're actually sending to the LLM and getting in response, okay? Other frameworks like CrewAI, like LangChain, LangGraph, AutoGen, these are all like big abstractions, okay? They are all wrappers on top of the basic functionality, all the functionalities, okay? There you have less control over what you send to the LLM, how the prompt is being
Yeah.
manipulated and being sent to the LLM and things like that. So if you have to start with how to build the agents, as per my limited understanding, I should say you should start with learning the OpenAI Agents SDK, which will let you to control exactly what you send and get back from the LLM. And then you start learning about the wrappers on top of it. That will help you to know what tweaks will get you what results, okay? So things like that,
Yeah,
right?
I think that is correct, and I would like to add there. I would say don't maybe probably don't use any library at the starting when you create an agent. Okay, you can directly code it. I mean, not you coding it, but the cloud code or codex you can use to code it directly without any this LangChain kind of library. So you will understand it better. But I think before you go there, I guess there are a lot of concepts to know. I think before you start coding the for the agents, because
Hmm.
LangGraph is mainly for agents, right? LangChain is for I think RAG related development. Or
What?
LangChain came first actually. I think
Hmm.
for agents, then they created the LangGraph library.
Hmm. Hmm.
Yeah,
Hmm.
that's what I understand.
Uh, yeah.
And I think there is one more called LangFlow as well.
LangSmith is there, one more tool. So
LangSmith
there
is
are
there,
three
yeah.
things are there:
Correct.
LangChain, LangGraph, and LangSmith. LangChain I
That's
haven't
right.
used, but what I know of from different sources is what it gives you one sequential flow of execution amongst the agents. Okay, and
Right.
LangGraph gives you a graphical way to execute your agents in a flow. So graph is like a tree, so you can decide which way to go by adding some fixed edges, conditional edges, and stuff like that. And LangSmith is
Right,
just a
right.
monitoring tool which is given by LangGraph out of the box for you. You can directly view all the what you say monitoring stuff in LangSmith. That is just a monitoring tool like Prometheus and Grafana stuff like that. So LangSmith is nothing. Okay, forget about that. That is not important. But LangGraph is the hot thing now, is what I understand. And if you want to know about building agents as such, so an agent is nothing, it is just an LLM with tools, right? Like your chat GPT, attach the tools to it, it becomes an agent. And you can just use, say, for example, OpenAI SDK for calling the LLMs and create your custom tools and attach it. No need to use even the OpenAI agents SDK, okay? That will give you the utmost no abstraction for playing by build agents. So look at that. If you want, I just did a small course, okay, on agents. That's why I'm able to say these things, okay. And there is a course on Udemy by Ed Donner. I can ping that in the WhatsApp group. You can take a look at that if you have bandwidth. That gives a very good broad eye view, a bird angle view of things like how agents are made, what are agents, and what are different ways to create agents. There are a hell lot of frameworks, Arun. Google ADK is there, Hugging Face, small something is there. I mean, gazillion agent frameworks are there, but you choose one and stick to it. That's it. Okay.
Yeah.
That's about agents. Okay, fine. I can give more info on the agents in the upcoming sessions. Okay, if you want me to talk about that, I can just revise those things and come and talk about those things one by one, framework by framework. Okay. So if you want
Yeah,
that, I
yeah.
can do that in upcoming sessions. So RAG, if you want to start about RAG now. we can talk about RAG. Start with RAG.
Yeah, sure. But I think just to start with the even more basics, right? I just want to know, like, maybe I think we should talk about these tokens, embeddings, and all first. So
Hmm.
I don't know if you are already because it is basics, right? If you are already aware of that tokens and embeddings.
We can talk about it. Shouldn't take much time.
Okay.
Yeah.
Yeah, if you guys know these things, let me know. I'll just start with that. And I have not, what you say, I have not planned anything or revised as well. Okay. So maybe I'll be jittery.
That's okay, man.
Okay. Okay. First of all, we talk with the natural language with the LLMs, right? So, but the machines as such won't understand the English or any other language. It just understands the numbers, right? So, first thing is that whatever we put into the chatbot will be converted into the a format of numbers, right? So how do we convert the numbers is that let's say we type some words, okay? I like cooking, maybe something. So this will be converted into kind of a vectors, or before that a sentence like this will be cut into multiple words, that is called tokens. Okay, it can be on like a, let's say, even a dot or comma also can be one token. Okay, so then each token will be converted into an numerical format called vectors. Okay, so say something like this. The I will take the form of a 0.32, 0.12, or 0.456. Okay, so and like will take the format of like 0.91, 0.002, 0.32, something like that. Like that, again, one more. Cooking will take some values. So this is a three-dimensional vectors, right? The word, each token is represented in three-dimensional vectors. Okay, how do you see the meaning of these vectors now? Let's say how does an LLM understand I, what is I means, or what is like mean, or what is cooking means? Okay, so here I have represented only three dimensional, but it might have something like usually 384 dimensions. I think that's kind of a starting point. Then it goes into 768 dimension, then 1000 something, 1096 or something like that. There are multiple dimension. I think goes up to 12,000 or 16,000. Um, but I think any number of dimensions you can use. It's not like 384 only. You can use like 350, 385, 385, 386 and all. But who will convert this one? That is again deep neural network called embedding models. Okay, these embedding models will convert this. These embedding models are already developed and available as libraries in the in a lot of places like Hugging Face and all. You'll get that. So you just put the words or yeah, word or even the sentence into it. It will convert it into vector format and give. So that is one thing. Another thing is that you can actually convert whole thing as into a single vector. Okay, that is also there. Okay, I just now talked about converting each token into the embeddings or vectors. Okay, but okay, let me. Okay, now how this computers understand this, what is this token means? Okay, by seeing this vector, it understands, it should understand something, right? There should be some reason why there is a value 0.32 here, 0.12 here, and 0.456 here. Okay, it's not like it's randomly put here. For one specific embedding model, this value should stay exactly the same. In the sense, if you ask, let's say embedding model is there. If you ask, give me the embedding of word cooking, it should always return the same vector, right? And let's say that you put a you ask for the word food. What is the vector for the word food? Then it should return a vector which is almost near to the cooking, because cooking and food are something related. Okay, so that's how machines understand, like, okay, seeing the vector, okay, this is the meaning of this word or that vector. Okay, just to understand, make that little bit more clear. Let me take the word cooking and food only. Okay, or I think it's a bit difficult to. Okay, I think last time I don't know we talked about king and queen, right? I
Yeah.
think I'll take that because that is much bit easier actually. I don't get good this one.
Maybe
Okay,
cooking
so
or baking or something like that, right? Boiling,
cooking, baking,
baking,
yeah, yeah, yeah,
baking,
yeah, yeah,
cooking.
yeah, yeah. Cooking also we can take actually. Let me see if I can cooking. Let's say okay. So now we will have multiple values in this 384. Let's say we are talking about 384 vector, 384 dimensioned vector. Okay. So now each this one, right, each value should represent something. Okay, let's say cooking here is that, let's say first dimension is food. Okay, I'm just randomly giving the attributes. Usually this doesn't work exactly like this in the embedding models, but the general and conceptually how we should understand is this way. Okay, how cooking is how or like let's say cooking has an attribute called food. Okay, cooking has an attribute called food. So how much it is related to? 0.98. Okay, 0.982, let's say. Okay, that is my first dimension. Second dimension is say rain. Okay, how much rain is, how does cooking have a attribute called rain, or uh, how much rain is getting affected to the cooking, something like that. Okay, it's a relation between that. You can think that cooking is something having some attributes, and these attributes will define the cooking, the vector for the cooking. So rain, is it related? Maybe a slightly related, because during the rain you will do some kind of cooking, maybe. Uh, so
Pakoras.
yeah, yeah.
Okay.
So like that. Okay, and fire. It will have again the this one maximum values, right? Something else like say earth, maybe very less, or or let's say a word called non-cooking, that will be almost 0.0002 or something like that. Okay, so that's how the vector is built. Okay, then for the baking also same thing. You say food, it will also be almost having 983 some values. Okay, so what is the difference between cooking and baking? That value will change maximum. Like baking is with the oven, right? So then this will have a more value for the oven, and probably here oven is there. this will have much lesser value for because I mean it's still cooking only with the oven, but yeah, it will have slightly lesser. So that's how the value of the word or the meaning of the word is differentiated by the computers. Okay, and one more way to think about it is having this multi-dimensional imagination. Okay, so you have this vector, you can plot this vector. Okay, in the this is a three-dimensional vector. Okay, so I'll plot this three-dimensional vector somewhere. Okay, it will come like this to this point. Okay, vector is the magnitude and the direction. Okay, so this is the magnitude of it. This is the magnitude of it in this x or whatever dimension. In one more dimension, whatever the magnitude of it, and this is the direction. Okay, so your this one will come here. The let's say cooking comes here. Okay. Now let's say some non-related word, rain. Okay. Rain might completely go into different direction itself because it is when you plot the value, when you plot the vector, it might go into the different direction itself. Okay. And say if you plot the baking, okay, baking might come here almost nearing to the cooking because they are similar. Okay, that's how the computers know whether two vectors are similar or not. So there is a thing called cosine similarity. So that is calculated with the
Dot product?
dot product. Okay, dot product of two vectors. Say this is u. Say the first product is sorry, first vector is u and second vector is v. Say this vector is u and this vector is v. Then you will write like u magnitude of u into magnitude of v into magnitude of v divided by product of u into v, I think. Even I forgot many things, man. So this is a distance of v actually. So it comes as I think square root of u square plus v square. Okay. Hey, just go back and check it. Okay, don't completely trust me.
Okay. Murray joined.
Okay, but Arun left.
Arun, he said he'll join back. He has to pick up his kid.
Okay. Hey,
Yeah,
Murray.
so,
Good.
hey, Murray.
Yeah.
Uh,
Okay, so
so, Pawan, to just sum up till here, right? So you have
yeah,
this sentence, I like cooking, which has three words. Then for every model, there will be a specific tokenizer that they use, which converts this sentence into a series of tokens, right? They can be words like I is one token, like is one token, cooking is one token, or they can be like for these three words, they can be five tokens as well. Like however, the tokenizer for an LLM decides to tokenize this sentence,
yeah, yeah,
these words.
yeah. Like cooking, cook can be one token, ing
Yeah.
can be another token. So even that can that way also it can be there.
Right. Right. So once we get the tokens, then each token for an LLM, we convert each token into a vector, right? Using
Yeah,
embedding model, right? Using an
embedding model.
embedding model, we convert each token into a vector, right? Now, depending
Yeah,
upon the embedding model's dimensions, if it is a three-dimensional embedding model, then we get these three number vectors, okay, three-dimensional vectors for each token that we get. The most common, the basic one is that, yeah, like you mentioned, which you saw in the RAG video also, is a 384 dimension that sentence transformer embedding LLM, which converts this embedding model, which converts this each token into a 384 dimension vector. So one vector is pointing to is corresponding to one token, right? And then you mentioned that whatever words or whatever tokens are similar, right, they will be plotted next to each other in the 384 high dimensional space, right?
Correct.
Then if you
Yeah.
want to find the if two vectors are similar, you use something called as cosine similarity, which we can
Mm.
calculate using the dot product of two vectors, right?
Yeah.
And
Yeah.
if the there's these numbers which you mentioned like 0.98 to 0.09 and so on and so forth, if you have the number closer to 1, these numbers will always be between 0 and 1, right? As per the RAG video. And if the value of these numbers is close to 1, that means the words are similar to each other, right?
Yeah.
If they are away from 1, means they are dissimilar from each other. Like you mentioned, food and cooking, they have 0.982. So a very close similarity
Mm.
between these two guys, these two
Yes.
tokens,
Yes.
right? And rain
Yes.
is
Yes.
totally ulta, dissimilar thing. So like that,
Mm.
correct?
Yes. Correct. Yeah, that is correct.
This is what
And
we have discussed till now. Okay. For Marie.
yeah. And cosine similarity, this is the formula. There is a cosine distance also. What is the distance between two vectors? That is 1 minus cosine similarity. Okay, that's all. I mean, just like terminologies. Sometimes they will use cosine similarity, sometimes they will use cosine distance. Okay, cosine distance equal to 1 minus cosine similarity. And the other thing is that now I mean, we saw like one word converted into the vectors, right? So we can also convert the full sentence or the paragraph into an vector. Okay, that's what is done in the RAG actually. They will create the chunks. Chunks can be multiple sentences, and then they will convert it into a single vector. Now, if you see here, I like cooking. If I convert it into this one new vector, let's say I'll convert it into a new vector. So our first attribute was food. So I like cooking is almost something related to cooking, right? So it still goes with something like 975 as the first attribute, which is food, and probably the second attribute is rain. If we consider rain as the second attribute, then it is again 0.09 1 maybe. Then third one is oven here. So it is again related. It will still stay very near to the cooking. Okay. So this there are different ways to do the embedding. You usually embedding models will give you this one, but you can think like, let's say I has one value. Okay, I has one vector. Okay, and like has one vector, and cooking has another vector, right? So you average this one. You average each dimension's value and build a vector out of it. Okay, you got it right. Like let's say 3, 6, 9, and here also I'm just saying 3, maybe 12, and 9 again, or maybe not 9, maybe something like 27. Here maybe 6. I'm just taking simple example of a vector, okay, for this 12, comma 30. Okay, maybe this one also for the easier thing, I'll make it as 60. Here I'll make it as something like 120. Okay, now you add these 3. 3 plus 3, 6. 6 plus 6, 12. 12 divided by 3, 4. Right.
Yeah.
and 24 plus 6, 30, 30 divided by 3, 10. Okay, like that, you will get the embedding of I like cooking. And if you see this, this also, this whatever the final embedding we get, right, it will be almost similar to the words what you actually use for averaging that values, right? So if you plot the I like cooking, then that I like cooking also will come somewhere near the cooking. Okay. And it will also be somewhere near I like. Let's say like is here. Okay. This is the word like. This is I like cooking. Okay. So it's like that. Okay.
Hmm.
See, your maybe the word earth, which is unrelated, might be here.
Hmm.
Okay. You have to think in a multi-dimensional thing. Okay. You understand, right?
Yeah.
So if your word I is here, if your cooking is somewhere here,
Hmm.
okay, and if your word like is somewhere here,
Hmm.
okay, so that is like this.
Yeah.
Okay, triangle, right? Your I like cooking word will fall almost in within that triangle somewhere.
Hmm. Hmm.
Okay,
Hmm.
you got it right. So yeah, that's how the vector for the or the embedding for the uh, sentence is done. And then if you compare this I like cooking and cooking, you can actually compare this similarity. Okay, those also will be almost similar
Hmm.
because they almost mean the same thing. Like cooking and cooking not mean the same thing, but they are almost nearby. It's
Hmm.
not different. Like I like cooking and I went for trekking is different than right than
Yeah.
I like cooking and cooking. So I hope I'm making some sense. Okay. So if you're not able to get it, I question me because I'm not a good orator.
Come on, man.
Okay,
Okay.
I hope I made some sense. So all the similar words or similar statements will be sitting together in the multidimensional space, or the dissimilar words or dissimilar statements will be sitting far away from each other in that in the multidimensional space. So whenever you find the similarity using the dot product or find the cosine distance using that dot product, right? That you will get it as a bigger value for the dissimilar vectors, and you'll get it as a near zero value for the similar vectors. That's all. That's the similarity. Okay.
So
That's
this,
the basis of. Yeah.
I mean, sorry, this one. So first we kind of found vectors for each tokens in a sentence, and then we averaged those vectors to find out the one vector for the whole sentence, right?
Correct. That is
Similar
one way of
of
one. That's only one way. Averaging is only one way, or the simpler way. There might be multi different ways to find the vectors or calculating the vectors. Okay.
Hmm. Okay, okay, okay. And similarly, in case of the RAG video that you shared, there we break the whole big document into chunks, and each chunk will have a vector. That is how it.
Correct.
Okay.
Exactly. Yeah. So one sentence can have a vector or you can represent anything in a vector format. Okay. Even the image in the vector format,
Hmm.
even the multiple, I mean, full document also you can represent in a vector format.
Hmm.
So it is, you can think like that. You have a dimension, you have a multi-dimensional space. In that one, you try to represent whatever, I mean, you try to represent anything. Okay. Uh, Let me try to put it in a correct way. Um,
Pawan, shall I
say,
close this meeting and restart the meeting? It is winding up in 2 minutes.
okay, I'll try to say something. Once it closes, you just ping the
Okay.
URL, we'll join it.
All right. All right.
So see, uh, you have a methodology of where you have certain 384 attributes to represent anything. Okay. So now you want to represent a word with that 384 attributes, you can do it. You want to represent an image in that 384 attribute, you can do that as well. Only thing is that your image is more complex. Your 384 vectors may not be enough. You will lose the what do you say, precision, okay, or some values. That's all. But you can still represent. So whenever you represent a bigger document, right, let's say 1000 token documents or 2000 or 10,000 token documents into one vector, you will lose the precision and you will average out everything. It means you will average the feel of or the crux of that whole document. Okay, your values are averaged. You will not be able to find what is the real thing it was saying. Okay, you just think in the multidimensional way. So you have a lot of vectors, okay, and you are trying to average it. Okay, it will come and stand in one point. Okay, so it's like that. So you can represent it in any you can represent anything in the vector format on any dimension. Higher the dimension, more the precision of the vector. If you use like 768 dimension, you will have better precision or the better representation for a word. Okay. Okay, I think it's going to close now. So
Let me do
okay,
that.
but yeah, but let me know if you are not understanding. Okay,